Almost a year ago, Software Engineering Daily aired a week of shows about decentralized technologies like Bitcoin, Ethereum, and IPFS. Bitcoin has established itself as a stable, decentralized financial network, but that's all it is. It's only used for financial transactions. Ethereum has much bigger ambitions. It wants to be a global computer built on the blockchain, but it does not yet have the adoption and stability of Bitcoin. IPFS is a distributed data store with an incentivization layer where you can pay strangers to store your content. And on today's episode, we're going to discuss all of these things. Today's guest is Karl Floersh. He's an engineer working on decentralized technology. Karl has written several posts about how to build decentralized applications, and he also writes a lot about how the future might look once these decentralized technologies have gotten some traction. It's a really fascinating conversation that projects far into the future as well as into the immediate 1 to 2 year time horizon. I want to take a moment to thank you for listening to the show. If you enjoy it, please share it on Twitter or Facebook or whatever your social media platform is. Tell your friends. That translates directly to growth and revenue for this show, and as the revenues grow, we will be reinvesting into Software Engineering Daily, and you can help keep that flywheel spinning by sharing it with your friends and helping us grow. Thank you so much for listening, and if you ever have feedback, please send me an email, send me a tweet. I always am looking for feedback and want to know how to improve, so please let me know, and I hope you enjoy this episode. This episode of Software Engineering Daily is sponsored by Braintree Payments. Mobile app development can be complex, but integrating your payments no longer has to be complex. With Braintree, your business can accept nearly every type of payment from any device with just one integration. Learn more at braintreepayments.com/SEDaily. Braintree's API supports Android, iOS, JavaScript, and many other languages. The documentation for Braintree is clear and elegant, and if you're integrating payments into your app for the first time, you can call Braintree's customer service and get assistance with your integration. Don't get frustrated when you're trying to integrate payments and monetization into your app. Go to braintreepayments.com/SEDaily and monetize your app today. braintreepayments.com/SEDaily. Now let's get on with this episode of Software Engineering Daily. Thanks for listening. Karl Floersh is an engineer focused on blockchain and other decentralized technologies. Karl, welcome to Software Engineering Daily.
Thanks, Jeff.
So almost a year ago, we did a week of shows about Bitcoin and Ethereum and these other decentralized technologies. And I walked away from those shows with the feeling that blockchain technology is going to have a massive impact on our lives, but nobody knows when that is actually going to happen. How long is it going to be before decentralized technology actually affects my day-to-day life?
That's a good question. I would say it depends on who you are, because if you are so it won't have, let me just start over. Blockchain technology is going to affect our lives in the next, just a few years, maybe a year, 2 years. But the thing is that no one will realize it's affecting their lives unless you're actually working with the technology. So it's going to have an effect on the way that banking works. Every single bank has a department that is looking into blockchain. But people are not going to, user-facing apps are not going to realize, that they're using any kind of blockchain technology. And that's by design. We don't want to confront the user and say, you have to change the way you work so you can use this cool tech. That's just not how it works.
So are these companies like Ripple or perhaps, like remittance-based companies, are these the first companies that are going to affect the way that we do day-to-day life?
I would say that Ripple is definitely one of them. Actually, Ethereum is another. The there are a number of blockchain technologies. The biggest ones right now are probably Bitcoin, Ethereum, and you could say open ledger. People are looking into open ledger, but it's really the idea of smart contracts. Even not even talking about blockchain, it's really smart contracts that banks are really think is going to be very powerful for them, because they need a way to execute code, execute logic in a consortium style arrangement where they can trust that the execution of the code is going to be fair and it's verifiable, but without providing a lot of friction for that execution.
Right. Okay. So we'll talk about this stuff in more detail, and we have some shows in the backlog about this. But before we get into the technical details, I would like to get more insight on, like, what are the impediments to widespread adoption of blockchain technology? Because my sense is that, in large part, a lot of the tech is there. Like, it's been written. It's pretty good. I know there are certain technical snafus, but my sense is that there are different impediments to widespread adoption that are more based in like cultural adoption, or just like people don't really understand it well enough, so they're scared of it. Is that accurate?
Yeah, that is. There's a huge barrier culturally, just understanding what blockchain is and why it's even useful. And it's actually not only a problem with the people who are learning, it's also the people who are explaining what it is. A lot of the developers that are working on blockchain are coming at it. They're contributing to the technology, but they're not contributing to the learning resources. So there is a huge cultural element there. From the technical side, the number one thing that is holding blockchain back is scalability. Just to put that out there. Right now, there is Bitcoin is it can transact 5 transactions per second. Ethereum 20 transactions per second. But credit card companies are doing thousands, if not millions, of transactions per second.
Okay, well then let's get right into it. What are the scalability limitations that are infringing on Bitcoin and Ethereum from scaling?
So the scalability, it comes to the fact that every single Ethereum node or every single Bitcoin node is running a full copy of contains a full copy of the history and is running a verification of every single transaction on the network. So if you think about that, imagine it's like a distributed system that has no sharding, that every single computer is running the entire every bit. So that is a clear. There's no way that can scale. That's just.
But I thought that all of the transactions, you do have to have all of them, but basically they all get kind of rolled into the tip of the Merkle tree. So it's not like you actually have to do a calculation against the entirety of the tree.
Yeah, so using Merkle trees, you get efficiency gains, like huge efficiency gains. But there's still that limiting factor of having to do anything really with every single transaction. Like there has to be some kind of manual intervention, and that's why the holy grail probably for scaling is going to be some kind of automatic sharding mechanism where you have like lightning networks or basically chains, smaller chains that you can then move into the main chain. And maybe only a few people are actually running a full node, and most people are running these partial nodes, and they don't even realize it because that scaling mechanism actually goes on in the background.
Okay, so I want to talk more about those things, lightning networks, but let's give people somewhat of an overview or a review of the two main decentralized technologies, at least the ones that you're most interested in, which are Bitcoin and Ethereum. And Bitcoin has established itself as this very stable network, but like you said, it can only be used for financial transactions, and it has even more scalability limitations than Ethereum, which is the other technology that you're very interested in. Ethereum is not just for financial transactions. It's a global computer for any type of computation, and it has a much bigger vision than Bitcoin. Give us more of a summary of the technical similarities and differences between these two protocols.
Yeah, so we can start with the cultural difference. So just like we talked about the cultural impediments, there's a fundamental cultural difference between the Bitcoin community and the Ethereum community. And that really drives what these technologies begin to look like. So the Bitcoin community is very much, there has been a lot of talk in the news about scaling Bitcoin and how they can't increase the block size, and that's just done a lot of it's given Bitcoin a lot of negative press. I don't think it's necessarily a bad thing, because it applies pressure to the system, and the system hasn't broken down yet, so it's actually, I think, getting stronger. But there's this like pressure to be stable and to be measured in the advancements in the Bitcoin community. It's like the stable version. And then Ethereum, from the get-go, they were saying, we are experimental. We're going to use the cutting edge technology. We're going to take risks. And we're going to hard fork the network. We're going to do everything we can to keep Ethereum on the bleeding edge. And that even comes down to right when Ethereum started blowing up, when the price went from something like $1 to $15 at one point. Right when this is the price of Ether. It's not really a good measure because this is just a technology. That's the interesting part, but for the finance people, they care. But when it was getting really popular and people were like, oh, we need to invest, Vitalik, who is the creator of Ethereum, gave a presentation basically saying that we have not even come close to finishing the Ethereum network, and that we are going to rewrite the EVM using WebAssembly, that we're going to, all these drastic changes, and that the hardest work for Ethereum is not even, we haven't even gotten to the hardest part of Ethereum. So it's like this idea of everyone staying on their toes, and we're all just trying to do this crazy stuff that we know is crazy. And I'm more into the Ethereum community, which is why I probably defaulted to the word we. But
well, it's very interesting because there's these two sides that you're kind of contrasting. There's Bitcoin, which seems rooted in like serious pragmatism, and then there's Ethereum, which is more leveraging the idea that there's this big vision, and obviously, there are downsides to both of them. If you go with ruthless pragmatism, you may not get people like yourself who are excited acolytes who want to, think about the most ambitious things that could potentially be used in the future. But on the positive side, you do stay grounded in reality, which sort of gives you a sense of like maybe a consistent progress forward, whereas Ethereum, you have contrasted this idea of the governance problem. So like Bitcoin has governance problems, but Ethereum does not have governance problems because it has this focused leader that people really believe in. But you can imagine that if Vitalik, died tomorrow or something went horribly wrong, then that would be totally catastrophic for Ethereum. Whereas I get the sense with Bitcoin, there's so much momentum already, and it's not really centralized in any particular leader, that Bitcoin, in a sense, has a little more failover. So how does that lead to how much progress these two projects actually make? Because I can imagine there's pluses and minuses to both of them. With Ethereum, if you have this velocity that's maintained by this really, really strong charismatic leader, maybe that leads to really fast feature iteration, but maybe it leads to complete chaos. And then with Bitcoin, if you have this total lack of significant leadership, maybe you can just get mired in bureaucracy. So I don't know, contrast these two a little more.
Yeah, you pretty much hit it spot on. The Ethereum project versus the Bitcoin project is really this. The Bitcoin is this slow but resilient and powerful. It's like a turtle. It's a turtle on jetpacks because it's a good it's moving at a pretty good pace, and they have it's an amazing code base. But the Ethereum project is moving really, like, they want to solve scalability within the next year or 2 years. They're changing in Ethereum. Bitcoin and Ethereum both use proof of work, which is basically to put things onto the network, you need to pay for it, and paying for it is equivalent to burning electricity. But Ethereum is going to ditch proof of work and move to a proof of stake algorithm, which is basically this interesting recursive financial game, really, where everyone puts money on the fact that the network is going to exhibit a specific state at a specific period of time. And if they're right, then they get rewarded. If they're wrong, then they lose their money. And so it gives this, it's kind of how our financial system is working right now, because everyone's betting on the fact that the financial system is going to continue, and that's why it continues. So they're going to change the entire consensus algorithm within probably the next year, year and a half. They want to create, fixed scalability. It's just like insane. They want to redo the EVM. Just kind of crazy pace. It's a crazy pace, but at the same time, it is definitely very risky, because I don't know if there's huge question marks if scalability is going to be able to be solved, or if proof of stake works in the first place using the algorithm that they're proposing.
So that's very interesting. I hadn't really heard the description of Ethereum as this sort of prediction market for how the state of the global computer will be in the future. What is your sense of the technical management of Ethereum? Is it up to snuff? Like, I mean, Google, for example, right? Google is able to execute on amazing projects only because they have put so much effort into the management structure. I would say the same for all of these other super powerful technical organizations. Although maybe Ethereum is more like Linux, where you kind of have this managed chaos by virtue of the way that the project is structured. I don't know. So give me a sense of the governance of Ethereum.
Yeah, so Ethereum, I would say the closest comparison is the Linux Foundation, where you do have this benevolent dictator, and you have a lot of people kind of working within that vision. And the closer you are to Vitalik, probably the more say you have on the protocol level of the network. And then the rest of it is just developers like myself who want to contribute to this cool technology. And so on a fundamental level, there exists the programming language, which is used by the EVM, the main one. There are multiple implementations, but the main one is called Solidity, and that is just it's a basic programming language, but it is focused on this distributed network. And so you have the concept of addresses, and you have the concept of money baked in. And so it has a lot of these niceties. So that's about the extent of what, the core Ethereum people have. They created this platform, right? And then they said, everyone do what you want. And so now there are a bunch of organizations, including Consensus, which is where I work. And there's also, Nexus Dev, and there are a bunch of other dev shops that are just sprouting up around this technology. And so it is a little bit chaotic. It's like that you open the floodgates for these distributed applications, these decentralized applications, and now everyone's doing whatever they feel is best. And so I would say it does lead to a kind of, if one leader is going the wrong way, then there'll be a lot of people who follow them, and they'll go in that direction, and that might not be perfect. And so then there has to be kind of a change in the momentum. So there's no it really is. It's not only besides that benevolent dictator who's controlling the protocol, there really exists a decentralized developer force. Almost even more than you could argue that it's even more than Bitcoin, because Bitcoin has the core Bitcoin client, And that is the state of truth. That is like what everyone uses for Bitcoin. But Ethereum, their protocol is actually defined in mathematics and, a paper, a white paper, a yellow paper. And then there are something like 8 Ethereum clients that exist that all run the protocol, and they all kind of work. And so you get this, every organization that is seriously in the Ethereum space has like developed a Ethereum node. So it's very interesting. They're main organizations, but they're all, I don't know. It's crazy.
Well, so when I did reporting on Bitcoin and Ethereum last year, there was this feeling I got from the Bitcoin side of people that they seemed to think that Ethereum was inherently problematic. Basically because of all the reasons that Bitcoin, or basically for all the reasons that Ethereum contrasts with Bitcoin. And I have to admit that I let the Bitcoin people win me over. And I ended up doing an entire episode called Ethereum Skepticism, which I kind of regret because it was just like a little prematurely judgmental, and I let myself just get swayed by the other side. And and clearly, like, not everybody portrays it as a us versus them sort of thing, but there are some people on the Bitcoin side and probably some people on the Ethereum side who just think the other side is completely moronic. So, I mean, why are people on the Bitcoin side so skeptical of Ethereum? Do they think it's this lack of mathematics, this lack of formalism? Are they thinking that people are just getting caught up in the mania of Ethereum and the vaporware and the bright decentralized vision that will never come to fruition? Give me an idea of why people on Bitcoin's side are skeptical of Ethereum.
So after Bitcoin was created, there was the age of the altcoin, essentially, where you had a new coin getting created every few weeks. And why were they getting created? Okay, maybe there was some validity to a lot of them. Maybe Namecoin using Bitcoin for DNS. That is kind of cool. But there are a bunch. I mean, I don't want to say Dogecoin because I just know the name is like incredible. The fact that we have, an economy for Dogecoin is amazing to me. And so there was this get rich quick ability that you can create your own altcoin if you know what you're doing, say that it's legitimate when it's really not, and people will start paying you, just making you hold a stash of the coin and you distribute some of it, but then that little bit gets value and now you have tons of money. So there's this skepticism that was baked in for good reason for many, many years. And then Ethereum comes along and Ethereum's like, we're going to totally take over and we're going to rethink the whole thing and we're going to build this amazing programming language and it's Turing complete and we have all these incredible visions and now give us money. We have a crowd sale. And so people are like, oh gosh, not again. And for good reason. But I think as time has gone on, the Bitcoin space has really opened up to Ethereum. For instance, I heard on a podcast, the CEO of Kraken, a major Bitcoin-focused exchange, was talking about how he believes that there is a place for Ethereum. So really, the Bitcoin community has warmed up. It's like the idea of Ethereum was so intense and so ambitious that no one believed it, but then they kind of executed on it, and it turns out that there is benefit and there is a serious value proposition for Ethereum. Ethereum was really the first very different decentralized blockchain protocol.
Well, it's yet another one of these things where it's like, if it works out, it is going to be incredible, and anybody that invested in it early on is going to be rich. And if it doesn't work out, then it will go to zero. And it is almost an aesthetic judgment as to whether or like how you feel about it. And in some sense, like the aesthetics, I think the aesthetics discussion also applies to the whole Dogecoin thing. Like, Why are you buying Dogecoin? You're buying it because of the name. Why do people buy brand name clothes? Because of the name. And it's almost like a statement on what you believe about the future. I don't know, but we don't need to go there. We can go. We could get. Let's stick to the technical track. So we did a show about Bitcoins. Bitcoins like newer features. There's these side chains and Lightning networks, and side chains and Lightning networks they're being developed to give Bitcoin a broader range of functionality, as I understand. So what is the functionality that Bitcoin is trying to build on top of itself, and how does that compare to the broad vision of Ethereum?
Yeah, so Bitcoin has there's the Lightning network, which should come pretty soon, and there's the side chains. And so I guess I'll start with the Lightning network. The Lightning network, on a high level, without getting into crazy details, reorganizes transactions and makes it so that you can have these kind of local, provably fair transactions that will then eventually go to the Bitcoin network, but they won't overload the Bitcoin network. So you have this kind of localization of transactions, which is very useful, and that is very exciting that it's coming, and it's been a long time. Side chains are essentially a blockchain that is tacked on with Bitcoin, and you have this ability to freeze your Bitcoins until the side chains coins come back. And it essentially, what you do is you merge mine, and you can mine both Bitcoins and the side chain coins. But the thing that's interesting about this is that what you end up doing is you end up creating more points of failure. So you have to maintain the sidechain network independently of the Bitcoin network. And what that does is that if the sidechain gets compromised, that affects actual Bitcoins. And the reason why that kind of compares and why Ethereum has a bit of a solution for that is that if you create a token within Ethereum, and that is essentially a token would be equivalent to creating a one contract, which is basically a class, if you're familiar with Java or something. And inside that class, you would have a field saying, which is a hash map, or it's a mapping in this case, or a dictionary saying tokens. And you have a person's name, a person's public address, and then a value amount of tokens. And then you have simple methods inside that say transact or create more. Maybe the owner can create more total supply. So it all lives. All of this logic though lives within the Ethereum network. And so when you're mining Ethereum, you're actually supporting all of the validation of these coins that live within Ethereum. So if the Ethereum network gets compromised, then yes, those coins get compromised. But on the other hand, on the blockchain network, if the Bitcoin network is not compromised, that's okay. But the sidechain network can be compromised, which would affect the actual stakeholders and their Bitcoins. So it's basically another way to do the same thing. And there are benefits and downsides of both.
How do you think the two coins or the two economies are going to be trading with each other in the future? Because obviously Bitcoin's not going anywhere. It seems like Ethereum's not going anywhere. My view is that these things are both going to develop. We're going to get to this amazing decentralized future, but along the way, we're going to have some plumbing that allows Ethereum to interact with Bitcoin. So what is that going to look like?
I would say that the closest thing to Bitcoin and Ethereum interaction, or Bitcoin and any other system interaction, would be right now we have exchanges, and these exchanges are owned by a company and they manage the transactions. But you can actually take this exchange and you can put it on something like the Ethereum network, and you can create a decentralized exchange where the exchange the program on Ethereum will hold Bitcoin. It has to be frozen and prove that it's frozen. And then you're able to basically prove that using things like oracles and whatnot, that one network has transacted value and given it to, one thing on one network has transacted with another thing on another network. But it's a lot of like, I think it's a little bit out there in terms of you can do decentralized exchanges, and that's like BitShares. BitShares has the ability to do this decentralized exchange, but you have to get the kind of developer support behind it, and right now BitShares is pretty ugly and not as well maintained.
Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/SE daily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE daily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/SE daily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. Okay, well, let's talk about another piece of decentralized technology, which is IPFS. And this is obviously an important piece of tech. We had Juan Benet on the show to talk about IPFS, and he said that in order to understand IPFS, you can imagine Git layered on top of BitTorrent, and then you layer the web on top of it. So I still don't understand what IPFS is. So what is IPFS? What is it useful for?
Okay, in terms of a down-to-earth version of that, because I hardly even understand exactly what that means, but it's the easiest way is to compare it to what we have right now for the internet. So his vision is to take web browsers and the way that they work on the back end and kind of swap out the IP layer with the like IPFS magic. And what that means is, or it's not really swap out, but it's adding the IPFS on top. So the current way that the internet works uses location addressing. So you go to a DNS and the DNS tells you, okay, the location of that server is, and then insert your IP. What IPFS does is that it's all about content addressing. And so what you do is you hash your blog post, for instance, and you put it on IPFS, and now everyone who has the hash to your blog post can, download the blog post. So that doesn't sound very useful yet, right? Because no one wants to remember the hash. But what you can do is maybe you can use something like Ethereum and a smart contract to map domains. You can map a name to a hash of an address. And so now you have this ability to have some kind of DNS for the hashes of content. But that still doesn't solve the problem where if you go to facebook.com, you don't want the facebook.com from 2012, you want it from 2016. So the way that you can solve that is that you can actually use IPNS, which is like a name service, which you, instead of doing the hash of the content, you can actually use the hash of the public key. And so if you use that, then only the person with the private key can change the content. And so if you trust the public key, then you can trust the content. And so you go to the hash of that public key, and it will download the latest version of whatever that person wants you to see. And so you can actually just kind of take the internet as it stands with the IP structure, which has like flaws in that you don't, if you go to a blog post and that blog post is from 2012 and then you go to that blog post in 2016, number one, it's doubtful that it'll be there. But if it is there, it's very likely going to have changed, or the website will be upgraded in some way. And you wanted the first blog post. So it's useful to have this content addressing. And then if you couple that with the ability to do traditional kind of mutable or mutable content, then you get a very powerful system. And there's even more intricacies to IPFS. But
you've written a few blog posts about how to build actual decentralized applications. We've been talking about Ethereum and Bitcoin and IPFS, which are protocols or primitives that we can build on top of. Sometimes talking about these kind of feels like we're doing entire shows on TCP/IP or just like these super low level things that are not, I mean, they're very interesting, don't get me wrong, but a lot of the people listening, I think, to the show are people who want to build applications. They want to build Rails apps or Django apps, or they want to build some Java backend service. So rather than talking about protocols, let's talk a bit about how to build an actual decentralized application. First off, how do you define a decentralized application?
Yeah, so a decentralized application is basically an app that does not have a central server that maintains it. And so normal applications are run by a company, Google, Facebook, whatever it is, and the users connect to that entity and download the content. And that entity will also handle the storage and the account management and whatever else you can imagine. A decentralized application is an application that only has clients, basically, where you as a client can open up this application. There's no entity behind it, just your peers. And you can communicate with those peers. It's kind of how torrenting works, but it's torrenting with added functionality. And I'll get into that. So you open up the application and you're communicating with you can have accounts, anyway, you can basically mimic the traditional client server architecture, but only using peer-to-peer communications.
Okay, but these companies that build, they build replicated, they build, applications that are centralized in some sense, Facebook or Google, they have server replicas. So, I mean, in some sense, aren't those applications decentralized when they have replicas of all of, they have replicas of the database, they have replications of services, and I mean, is that so? I guess that's not the sense of decentralization that you're talking about.
Yeah, that's more of like a distributed kind of. I mean, these terms are still young, and so who knows really what they're going to mean. But the way the interesting thing is that it's actually, it comes down to who you trust, and this is a little bit philosophical, but you are either going to trust a company, Google, Facebook, you're going to trust a government, you're going to trust a bank, you're going to trust whoever, right? That's the traditional thing where they're these large organizations and you can trust them. And that is not broken. In our system, we can trust these organizations. And that's cool and that's great. The thing that Bitcoin innovated and Ethereum has used to try to take to the next level is you can now trust a network. You can have computers that do not trust each other, all working together and coming to consensus. And that allows you to trust a network. And so the fundamental difference between a DApp and an app is an app, you're using these traditional models of trust centered around organizations. And in a DApp, you're using this new kind of trust model that is built around consensus algorithms being run on a distributed set of computers.
Okay, great. So one of your posts illustrates the basic DApp architecture, and DApp is decentralized application. And this DApp architecture uses Ethereum and IPFS. So how do Ethereum and IPFS work together?
Yeah, so Ethereum is good for the trusting part, that truth that I was saying. You need to be able to trust an application to store maybe in a list of accounts, or if you want a Kickstarter application to store the funds during of the crowdfunding. You have this need for the actual application state, like the global state of the application. And then you also have a need for just storing data. And so we were talking about scaling and how that is a huge problem in Ethereum. We can't store every little bit of the application on Ethereum, and that, going down to the, minified JavaScript or you can't store all of that on Ethereum because of scaling problems. Instead, you can use something like IPFS. So you could even think of, in this case, IPFS is acting very similar to just a torrent. So you torrent the application, you download the application from a group of peers, and then now you have the application. It's just like any other web application that you're interacting with. But now whenever you say, okay, I'm going to update my account information, or I'm going to put money into a crowdfunding, then it's actually going to be using the Ethereum network, and that's where the trust comes from, and that's where your account lives. Maybe there's a list, once again, of public keys to account names, and so that's basically all of the accounts. And then you have a integer, which is just the crowdfunding current, money, currency, and all you're doing is you're subtracting from one account's value and adding to the crowdfunding value. So it's very similar, but the main difference is that trust displacement.
Would you say that Ethereum is very useful for storing rapidly, dynamically changing content, and IPFS is maybe more useful for more static CDN type of content?
I would say that actually it's about how much you care about the validity of content. So how accurate you want to be, because you pay a price. The more accurate you are, the more money you have to pay. And so what that means is you can imagine our data sphere as during a snowstorm. The snow falls, and the top layers of the snow are very light, and there's loosely packed, they can move around. But as you go down, you get to packed snow, and then you get to ice. And so the ice is like the stuff that's been in the blockchain for a week or for a day or something like that. And then above that, you have kind of the new stuff that's being added to the blockchain. And then you can even go up and you can start to see this fuzzy layer of just peer-to-peer interaction, where you're using things like WebTorrent, or you're using things like IPFS, where really all the people are doing, they're all holding the application state, and then essentially it's going to get checkpointed at some point, and then kind of solidified into the history of the universe. But it starts out fuzzy.
Okay, so let's go through maybe a small example. So let's say I'm building like a to-dos app, but this is a decentralized to-dos app. So let's say I want to build a to-dos app where anybody can post to-dos, and every to-do has a smart contract associated with it that, if you accomplish the to-do, you fulfill the smart contract and you get paid for it. So how would we build this kind of to-dos decentralized task accomplishment and payment app using Ethereum and IPFS?
Yeah. So first, of course, you need a GUI at some point, and so that can be, you can use any kind of GUI technology. Normally, it's web. The web is awesome: HTML, CSS, JavaScript. Then, once you build your to-do app, and let's say React and Redux to do, and then what you would do is you would put that application data into IPFS. You bundle your JavaScript and you bundle everything into IPFS. And within your front-end application, you have a library which communicates with an Ethereum node. And what you would do is you, independently of this application, you create an Ethereum wallet. And that Ethereum wallet is basically your account. And this account is very cool because we're actually there's work being done to create persistent identity. So it's native to Ethereum. And so every app will use the same identity and the same amount of money. So you create one app or one user, and that just goes across all your applications. But you use your username, you use your account, and you're already logged in. And what would happen is you download all of the current to-dos from Ethereum. There's like a list of to-dos on Ethereum, and then it just displays it on your web app, just like any other thing. And now what you do is if you completed the task and people are sure that you completed the task, then you click check, you click the check mark, and now it sends a transaction to the Ethereum network, which updates the state in the Ethereum network using a normal programming language for simplicity so everyone can use it. And that will trigger a sequence of logic, and that could be paying you out. That could be asking all of the other participants if you really did it, and then they have to check off that you actually did it for the payout to occur. And so you get this this organized group of people that are trusting. They don't trust each other, but they trust the network, and it's this organization, this facilitation of automation.
Perfect. That's a really good explanation. And I want to now talk about another Ethereum project that you are working on that's more complex, which is Ujo Music. And that's a decentralized platform for enabling musicians to get paid. So this is a great case study for explaining what decentralization can enable. So how does Ujo Music work?
Yeah, so right now the music industry has its problems. It's pretty good considering it's been around for 100 years. But there is this black box where an artist will sign up with a label or a PRO, and they won't get money for a year or 2 years. They won't get their royalties for a very long time, and it's kind of upsetting and it's sad. So Ujo Music is trying to fix that. But really, first, the Ujo part of it is actually, Ujo means container in some language that I don't know. And what it means is it's actually going to be a container. The idea is actually building a container for works. And so with the blockchain, with 3D printing, we lost the ability to kind of, this is an object in reality, and we are able to actually codify that object and make it manifest in three-dimensional space now. So it's this blurring of a line between what is digitally true and what is physically true, and we're getting closer to being able to cut and paste physical objects, which is crazy. Now, what that means is that we need a record of things. We need this. What is reality anymore? If we can now copy and paste everything, what is the original? What does that mean? And so we can use the blockchain and its permanence to record that reality, record this is the first person who downloaded the song by 2 Chainz. This is the first person, X, Y, or Z, Kendrick Lamar. And that's where this is where blockchain is really going to play a very important role in the future. But Ujo Music is going to take that concept, so it's future-proof, and apply it to the music industry as it stands today. So they're just like banks have a hard time coordinating. They want to make sure that everyone's playing by the rules and they don't trust anyone. The same thing goes on with music industry players. And so if we can create, and what we are creating is a application which runs on Ethereum, probably in a private blockchain setting for now because of scalability constraints. There's private which will facilitate the distributing of rights, the tracking of ownership, and it will do all of this in a way that is much more permanent than an SQL table.
Very interesting. Yeah. Okay. So I'm a musician. I've encountered these types of crazinesses that exist even today. My current workflow for uploading music to the internet is I use something called DistroKid, which distributes all of the music to iTunes and Spotify my username is the Prion. If anybody wants to look up my music and hear it, you've heard it on the show. But why is this useful to me? Like if I, how does this, because as a musician, all I really want is my music to be heard by people. Obviously, if it was blowing up, I would want to be remunerated for it. But my understanding was that basically you can't make money off of music distribution anymore. You only make money off of concerts or sponsorships or appearances or something. And sort of the idea that you actually get paid for people listening to your music, that's dead and gone, right?
To some extent, that is true. But at the same time, there's actually a revitalization this year in the music industry in terms of they created all these streaming services and exclusives like Tidal, which are horrible for consumers, in my opinion, but are great for artists that have a big name and can kind of use their name to gain a lot of, gain those monthly subscriptions. But this actually, your point and your question goes back to the fact that what is blockchain going to do to impact our lives, right? And the answer to that question is consumers, like artists, most of them are not going to realize they're using a blockchain at all. There is no reason to disrupt the current established user-facing experiences because they are pretty great. I'm not about to say that Ujo Music is going to compete with Apple Music. That's just not happening. And all the other services that are trying to compete in that space. But the value prop is actually goes into creating, facilitating the ability for, one example that is closer to the artist understanding that they're using a blockchain is there are services that are popping up where an artist can upload, it's like a record label, they upload their catalog and they can see where their money is coming from and where it's going. They have these nice GUIs that allow you to kind of manage your music and see where your money is coming from. And those things will be enabled by the fact that we are using a blockchain on the back end and that they're using kind of fair payment distribution. But maybe a more a further away from the user, but closer to their hearts, probably from the artist, I guess in this case, is the fact that if we can get PROs, if we can get large organizations to make their processes much more efficient, then both they can save a huge amount of money and artists can receive their paychecks in a timely manner, which is a huge win and almost pathetic that it has to happen. But it's not actually, I don't fault the PROs for doing their job as they're doing it. So,
well, what I do like about the Ujo music project is that the way that things are going, people obviously don't want to download an MP3 and just listen to it on their computer, but that is the workflow that kind of prevents artists from getting paid to the extent that they should be getting paid, because if you're reading from your local file system, that read never gets attributed to the artist. So the artists have no idea how many people are listening to listens on local playlists or local file systems. But as everything moves to the cloud, everything moves to streaming or whatever, you could have this centralized point where every read eventually gets propagated to, so that you can have this actual proof of record of how many listens a song has. So let's start to wrap up by kind of getting the bigger picture, because you've written about this bright decentralized future. You believe that decentralization will change how we work and how we interact, how we share resources. We started off this conversation talking about how long this might take and the impediments to getting there, but I am with you that we will get there eventually. But obviously the question of how much decentralization will impact the world as we know it today depends on how long it takes for decentralization to materialize. So paint us a picture of the world that you think Ethereum could enable, or a decentralization could enable.
Yeah, so I wrote a blog post that predicts that in 10 years, a nice round number, we will see these massive shifts in the way that we interact with each other. And that will be facilitated by the easy access to a credible source of truth that blockchain technologies enable. That kind of future would probably look something like facilitating an easy way for you to move from one location to another, because you have your reputation. It's actually very tied to reputation, because you actually are able to own a reputation in a way that is not as dystopian as owning a reputation through Google. You don't want Google to assign you a credit score necessarily and for every aspect of your life. But it feels a little bit nicer if you can control that credit score. And that credit score is not just for credit, but that is for, how, it can span your, how well you pay rent, how often you pay rent, all these kinds of, every single interaction that you have can contribute to your personal identity. And then what you can do is you can leverage that identity to lower the friction of interaction between humans. So this is it's kind of a down the line. Let me say that again. Being able to leverage a blockchain, a single source of truth that you have control over, could enable the the lowering of friction between human interaction, and people can basically get to know each other by sharing their data with the other person, and they now have a record. For instance, like an eBay buyer, right? And you can expand this to all parts of your life, where an eBay buyer has a score, and they have an eBay seller has a score. And so if you want to buy or sell, it facilitates that interaction because you have this history, this immutable history. Now, if you take that and you make it super easy for new developers to create that history, like using smart contracts, Ethereum. It's very easy to write a few lines of code and create a new reputation system. So if you're able to get that network effect of developers, you're able to see these scores being used in incredible ways that facilitate interactions.
Well, you are starting to see these better kind of credit score type of things work in real life even today, just not in sort of the decentralized fashion that you're talking about. Like obviously the problem with credit scores, the problem with FICO scores is that the technology behind them is so bad, so antiquated. It's just not really fair. It doesn't even make sense. But there are more modern companies like Affirm or, I think about like Amazon, right? Like when Amazon decides whether or not they're going to let me return an item, or when Amazon decides they're going to offer me some sort of deal. It's essentially based on their back end systems that are processing how creditworthy I am and how much they want to give me. Facebook they recently got a patent on some kind of social thing that's going to let them offer money based off of people's social network strengths. So there are obviously all these opportunities where an organization with credit or capital could extend an offer to somebody who does not have credit or capital, but whose life obviously shows so much promise that it totally makes sense for that organization to invest in that person by giving them capital with some kind of interest rate or some sort of, loose interest rate. There's also SoFi. SoFi is doing stuff like this. I think this is like actually really, really, a really, really, really big deal. The financial servicization of what decentralization can do, and we're already seeing it still in proprietary platforms, but I can totally see it being formalized and decentralized into something like Ethereum or some other blockchain. Yeah,
what you talked about is all of these different organizations that we trust. They're creating these scores. Mm-hmm. But when you open it up to a 15-year-old developer that decides they want to write a smart contract for how to trust, this thing that you never imagined would even have a score related to it, that's when you start to see real innovation. It's like where we used to have these silos of technical advancement, but then we gave everyone a computer, and now we can see what happens. So it's really about enabling those network effects and giving everyone a platform that they can trust.
Okay, Karl, this has been a great conversation. The time flew by. I want to thank you for coming on the show, and I know you're a longtime listener, so I really appreciate your listenership. I appreciate you you coming on, and I look forward to talking to you and maybe doing another show in the future.
Yeah, that would be awesome. And I thank you so much for this show. It's every day I wake up and I put on a Software Engineering Daily episode. Got to stay fresh with the tech. So
that's great. Okay, cool. Well, thanks so much.